Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll discuss a concept of force exerted by the jet on a stationary vertical plate. So what is the force exerted by the jet of water on a stationary vertical plate? So the plate condition is vertical and stationary. So for this, this diagram was taken from the book. So we'll discuss about in details regarding this. So first of all, we need to consider a jet of water. So here, this is the jet of water is there, is indicated here. You can see. Suppose this is the pipe is there. This is the pipe is there, and through this pipe the water is flowing. It is a long pipe is there, and through this pipe the water is flowing, and here there is a nozzle is connected to this pipe. Okay, so that you can see the area of this nozzle was decreased. Okay, so up to this it is a normal pipe is there, and where the diameter is fixed. Okay, and here you can see it is in decreasing diameter, that means decreasing area. So once that area is decreased, we know that the velocity is going to be increased here. Okay, and again you can see the jet which is coming out from the nozzle. Okay, the jet which is coming out from the nozzle, so this jet will have another one diameter, that is we can consider that is small d. Okay, so first of all we need to consider a jet of water. We need to consider a jet of water. That means the water is coming with a jet speed. Okay, the jet of water is coming out from the nozzle. Okay, and that is going to strike to a vertical plate which is fixed. So this is the plate part we have considered here. You can see this is the hatching line is given to this plate, and this one, and these two symbols are given for fixed. So these two symbols we can see this is the plate is fixed here. So the jet of water which is coming out, that means the liquid which is coming out from this nozzle, it is going to strike over the plate. Okay, it is going to strike to the plate. So what we need to calculate here? We need to calculate what is the force exerted by the jet. So this is the jet. So what is the force exerted by the jet on the or on a stationary vertical plate? So this is the plate is there which is stationary, that means fixed, and it is positioned as a vertical condition. So the plate condition is vertical condition, first thing, and the plate should be stationary, not moving condition, because we have seen in the last class I told you that the plates can be placed in two types. One is vertical, another one is inclined, another one is curved, and the plate will be either in stationary condition or in the moving condition. Now here we are discussing about the stationary condition plate. So jet of water, next one is nozzle, and pipe is there, another pipe is there. So these are some parameters you can easily understand from this diagram. We can see this is the pipe and this is the nozzle and the jet of water which is coming out from the nozzle. And after striking here, you can see, okay, initially suppose this is the velocity is there, the jet velocity is there, and after striking here, so though the plate is fixed, we can see the water is moving along the y direction to upward. Okay, the water is moving upward directions. Okay, because the plate is fixed, so it cannot move in the x direction. That means it is not able to move in the force direction. That means at what direction the force is applied, it is not able to move in the direction. And after striking here, the velocity you can see it is moving in the y directions. So you can see that it's making an angle of 90 degree. You can see the jet of water which is leaving this from here, it makes an angle of 90 degree. Okay, so the component of the velocity of the jet, you can see we know that we have two components, one is x component, another one is y component. So here the component of the velocity of the jet, you can see in the direction of jet. See, jet direction is x direction. You can see the jet direction. The jet direction means it's which direction the water is moving, that is x direction. That is x direction, we can say. And here initial velocity will be like, what is the initial velocity in the sense at what velocity the fluid is moving or the jet is moving, that is v. So here the initial velocity, we can say initial velocity we can consider here v, what is given here. and after striking here in this plate at this point, in the x direction, it is not going to move. So the same velocity is deflected here from this point to y direction with a velocity v. So what about the x direction velocity? So x direction velocity is at this point, that will be 0. That means here we can consider the final velocity. The final velocity at the x direction is going to be 0. So the force exerted by the jet on the plate, okay, in the x direction or in the direction of jet, we need to calculate here, because that is our topic for today. So we can write the force, let me write the force exerted by the jet on the plate, on the stationary vertical plate. Just I write on the plate in which direction? In direction of jet, in the direction of jet, or we can say it is x direction. Okay, so this equal to, according to the Newton's second law of motion, we can write, so the force exerted or the rate of the force is equal to the rate of change of momentum in the same direction of force. So here we can write, so let me write, this is Fx, the force in the x direction. As I told you, this is our x direction and this is our y direction. So the force in the x direction, that can be written, so this is this one we can write, this is rate of change of momentum. The rate of change of momentum, the rate of change of momentum in the direction of force, in the direction of force, or in the x direction we can write, anything we can write. Here you can write this is x direction. So this one, the rate of change of momentum is nothing but, we know that this is initial momentum minus final momentum. So change of momentum, actually not rate of change of momentum, change of momentum only is nothing but, this one we can write initial, this is initial momentum and minus final momentum. Okay, this is actually change of momentum. So now when you talk about the rate of change of momentum, so here we need to consider, that is initial momentum minus final momentum divided by, with respect to time. We need to consider here with respect to time. So what about this momentum? Momentum is nothing but, we know that is mass into velocity. So mass of the fluid into what is the velocity of the fluid which is flowing there. So here we can write, this is momentum equal to, we can write this is mass into velocity. Okay, and here the same thing I'm going to write here. Initial momentum, we can write this is initial velocity, initial mass and initial velocity. So mass is not going to change, so mass will be fixed. So we can write this mass into initial velocity. Again I'll write here, yeah, so this one, let me write, this is mass into initial velocity. Let me consider this is initial velocity, suppose v1. Okay, let me initial velocity, let v1, and final velocity, this is v2 on in the x direction. So m into v1 minus m into v2, and divided by with respect to time. I told you that, so we can write here with respect to time. And what I'll do here, I'll just take a common of mass, because you can see mass is fixed here and it is not going to be changed. So the mass part we can take it to outside. So this one we can write mass and divided by time. So this one we can write, this is, okay, mass by time, and remaining part we can write this is initial velocity minus final velocity. Okay, again I can write this mass per second. Okay, so mass per second is nothing but we can say that one you can write m dot. So here I'll write, this is mass for, we can write this one m dot, yeah, mass by time. This one we can denote this by m dot, or we can write this one in place of mass, I can write here, we know that rho equal to mass by volume, and here again I can write m equal to rho into v. Okay, so here in place of this mass I'll write mass by time I have written. So what I'll write here, rho into v in place of m, divided by time is there. So this is time. Time is nothing but, we can write this in terms of second. Now this velocity, okay, velocity per time. So no, this is not velocity, this is our mass by volume. Okay, mass by volume. So volume per time. So this one we can write, discharge of the water. Okay, so now you can see this these things we can write m dot equal to mass per time, or we can write rho into q. So discharge q, this one, our q also we know that according to the continuity equation, if you remember, a1 v1 equal to a2 v2. So we know that the discharge also we can write in terms of area into velocity. So here I'll write rho a v. Okay, this is in place of mass per second. So same thing I'll write here in place of mass per second. I can write this is rho. Yeah, here area, what area you need to see here, what is the area? So area I have taken a diameter d, that means area equal to a equal to pi by 4 d square. So here I can write this is rho small a v, and similarly I'll just write here rho a v. And what about this initial velocity minus final velocity? So initial velocity, as I told you that the fluid is moving with a velocity of v, so you can write this is v normal. And what about the final velocity? Final velocity nothing but after striking in the x direction, the velocity is going to be 0. So the final velocity here it is 0. And finally we are going to get fx equal to rho a v square, rho a into v square. This is the force exerted by the jet on the vertical plate. So here we need to consider, see, we have considered here initial momentum minus final momentum, or we can say the initial velocity minus final velocity. So here we need to keep in mind that if the force exerted on the jet, if the force exerted on the jet, this is the jet of fluid, if the force exerted on the jet, okay, and then it should be calculated like final velocity minus initial velocity. Okay, but here we have considered the force exerted by the jet. One thing is on the jet, we need to keep in mind on the jet, and another one is by the jet. The force exerted by the jet on the plate. So that's why we have taken initial velocity minus final velocity. But here if you see on the jet, then what is the final velocity and minus initial velocity, this need to be considered. So that one, another one important point. And remaining part, I hope you understand. Still, if you are having any kind of doubt and query regarding this, you can give a comment on that comment box. Thank you all.